A man pushes a stick into the ground. The sun hits it, a shadow appears beside it, and from that shadow, he measures the earth. That sounds impossible, not because the story is fake, but because it sounds too simple. One stick, one shadow, one calculation, and somehow the size of the entire planet. No satellite, no GPS, no camera, no modern map, just sunlight, geometry, and a shadow on the ground. This was not magic. It was not a lucky guess. It was someone looking at something ordinary and asking a question almost too large for the human mind. How big is the Earth? Not a country, not a sea, not the distance to the next city. The whole Earth. The thing everyone was standing on. And before we talk about his name, think about the problem. How do you measure something you cannot step away from? If you want to measure a table, you stand beside it. If you want to measure a room, you walk across it. If you want to measure a road, you follow it from one end to the other. But Earth is different. Earth is not sitting in front of you. It is under you. You cannot walk to the side, look back, and see the whole thing. You are trapped on the surface of the object you are trying to measure. And yet, more than 2,000 years ago, someone found a way. His name was Eratosthenes, and he worked at the Library of Alexandria. It was one of the great knowledge centers of the ancient world, a place where people tried to gather what was known about the world. Maps, travel reports, mathematics, astronomy, poetry, philosophy, stories from places he had never seen. That mattered, because this measurement did not begin with one man staring at one shadow. It began with two places, and with someone who had access to information from both of them. The first place was Alexandria, the city where Eratosthenes worked. The second place was far to the south, a city called Siena. Today, it is near Aswan in Egypt. Eratosthenes had heard a strange report about this place. At noon, on the summer solstice, the sun appeared almost directly overhead. People said that vertical objects, and even people, cast almost no shadow at all. No shadow. That is the detail. A missing shadow. To most people, this would have been a curiosity. A strange thing people said about a city in the south. Interesting, maybe, but not world-changing. Eratosthenes noticed what was missing, because in Alexandria, on the same day, at noon, the sun did not behave that way. If you placed a stick straight up in the ground, it cast a shadow. Not a huge shadow, not something dramatic. Just enough. So now there were two observations. In Siena, basically no shadow. In Alexandria, a clear shadow. Same time, same sun, same day, different shadows. So the difference had to be somewhere else, not above them, below them, in the ground. To see why, imagine sunlight reaching Earth. The sun is extremely far away. Far enough that, for this kind of measurement, its rays can be treated as almost parallel lines. So if Earth were flat, two vertical sticks in two different cities should behave almost the same way under the same sun. The shadows should match, but they did not. In Siena, the sun was almost directly overhead. In Alexandria, it came in at an angle. That meant the sticks were not standing on the same flat surface. They were standing on different parts of a curve. The ground itself was curving. Now, Eratosthenes was not the first person to think Earth was round. Many educated Greeks already believed that. They had noticed Earth's curved shadow during lunar eclipses. They had noticed ships disappearing over the horizon. They had noticed that different stars appeared when people traveled north or south. So the clever part was not simply saying, Earth is round. The clever part was asking, if Earth is round, can we measure it? That is a much harder question, and the answer was hiding inside the shadow in Alexandria. At noon in Alexandria, the sun was at its highest point. The stick still made a shadow. If you know the height of the stick, and you know the length of the shadow, you can work out the angle of the sun. Eratosthenes found that angle to be about 7.2 degrees. At first, 7.2 degrees sounds like almost nothing, a tiny slice of a circle. But that tiny slice is the key to the entire measurement. A full circle is 360 degrees, and 7.2 degrees fits into 360 exactly 50 times. So 7.2 degrees is 1/50th of a circle. Now stop there. Because this is the whole trick. The shadow in Alexandria did not just give him a local angle, it gave him the angle between Alexandria and Cyane on the curve of Earth. In other words, the distance between those two cities was 1/50th of the way around the planet. He did not need to walk around Earth, he only needed one slice. Then he could scale it up. Ancient sources placed Cyane about 5,000 stadia from Alexandria, far to the south. In modern terms, that is roughly 800 kilometers, depending on how the stadion is converted. But that distance mattered just as much as the shadow. Without it, Eratosthenes only had an angle. The distance gave the angle a scale. It turned a small slice of a circle into something he could multiply. That is what made the measurement possible. A stadion was an ancient unit of distance, roughly connected to the length of a running track. The exact length varied, which is one reason historians still debate exactly how accurate Eratosthenes' final number was. But the logic is simple. If 5,000 stadia is 1/50th of Earth's circumference, then the full circumference is 5,000 times 50. That gives 250,000 stadia. Some ancient versions give the result as 252,000 stadia. Either way, the idea is the same. One shadow, one angle, one distance, one multiplication. And suddenly, Earth had a size. But this is also the moment where the story becomes suspicious. Because if it sounds too clean, that is because it is. Not fake. Just cleaner than history usually is. Cyane was not perfectly due south of Alexandria. The two cities were not exactly on the same meridian. The distance between them was an estimate, and the exact length of the stadion is still debated. So no, this was not a flawless modern measurement. The equipment was basically sunlight, geometry, and ancient travel estimates, which is not a bad setup. But it is not a satellite, so the clean version breaks. But the idea survives. That is the real achievement. Not a perfect number, a method, a way to measure something too large to see. Eratosthenes turned Earth into a geometry problem. Two cities, one sun, two shadows, one angle, one fraction of a circle. Once you understand that diagram, the planet stops being just the ground beneath your feet. It becomes something the mind can hold. A shadow became an angle. The angle became a fraction. The fraction became a distance. And the distance became the Earth. Today, the size of Earth is just a number on a screen. You can see the planet from space without thinking about how anyone first measured it. But someone had to understand Earth before anyone could see it. More than 2,000 years before satellites, Eratosthenes measured the planet without leaving Egypt. He did not need to see the whole world. He only had to notice that the same sun made two different shadows. And then ask why.